Commercial Distributed Control Systems, Part 5. In this part, we are going to discuss Process Interface for DCS. Process Interface. A typical plant with large number of variables contains abundance of process information, that is data. Therefore, process information can be classified under several classes or groups. Then a specialized device can be used to transfer all information of a specific class into and out of the computer. This way, designing different input-output interface for each inter-output device to be connected to the computer is avoided. In fact, most process data can be grouped into 4 major categories as listed in Table 2. Table 2. Categories of process information. According to this table, the first category is digital. For digital, input to the computer are in form of relay contacts and switch contact. The output of the controller shall go to solenoid valve or a motor drive. In the category 2, we are having generalized digital category, in which the input shall be from the laboratory instrument output, and the output shall be in form of alphanumerical displays. Third category is pulse or pulse train. The pulse train shall be coming from the turbine flow meter, and the pulse output shall be going to the stepping motor. Fourth category is analog, in which input to the computer shall be thermocouple or strain gauge in terms of millivolts, process instrumentation in form of 4 to 20 milliampere input. Other sensors shall be 0 to 5 volts. In the next few slides, we shall be discussing these categories in more detail. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. The first category is digital input-output signals. The digital input-output signals can be easily handled because they match the computer representation format. The digital interface can be designed to have multiple registers, each with the same number of bits as the basic computer word. In this way, a full word of 16-bit can represent 16 separate process binary variables and can be transmitted to the computer at one time and stored. Each bit will determine the state of a specific process input. For example, a state of 1 means the input is on and 0 means off, or vice versa. Generalized digital. The generalized digital information usually uses binary coded decimal and ranges from 000 to 999. Hence, a 16-bit register can be used as interface device to transmit 4 digits of result because 4 bits are necessary to represent one digit between 0 to 9 of binary coded decimal. Input pulse information. In the input pulse information case, a single register, that is interface device, is designed for each input line. The register ordinarily consists of pulse counter. The accumulated pulses over a specified length of time are transferred to the computer in binary or BCD count. The output pulse interface consists of a device to generate a continuous train of pulses followed by a gate. The gate is turned on and off by the computer. Analog input. The analog input information must be digitized by analog to digital converter before fed to the computer. Since the process has a large number of analog sensing devices, a multiplexer is used to switch selectively among various analog signals. The main purpose of a multiplexer is to avoid the necessity of using a single analog to digital converter for each input line. The digital to analog converter device performs the reverse operation. Each analog output line from the computer has its own dedicated digital to analog converter. The digital to analog converter is designed such that it holds, that is frees, a previous output signal until another command is issued by the computer. Next lecture. The name of the next lecture is Commercial Distributed Control Systems Part 6. In the next and subsequent lectures, important aspects regarding DCS systems shall be discussed. It is hoped that this session was useful to you. Please press like. Please subscribe.